Hi, I'm going to talk to you about my task, using and critiquing COVID-19 pandemic data to answer real-life questions. So first, a little bit about my audit findings. I audited the Year 9 science curriculum, the Science Understanding Biological Sciences section. Most of the numeracy opportunities are when the elaborations lend themselves to scientific inquiry. In Year 9, students study systems, so the body and ecosystems, so 2D and 3D representational tools are quite important. This is where my task fits in. This elaboration includes epidemiology. So my task was following a 5Es inquiry model. And in this presentation, I just want to talk to you about some of the elaborations that the students can do. So the students come up with some questions that they can answer using data, and then they choose a question for their elaborations. So here are some of the questions they might come up with. And the point is that they'll be looking at the pandemic from different perspectives with different mathematical concepts. So the first question I'm going to talk about is how bad is it? How does it compare to a bad flu season? And the students can compare the UK deaths in the last 5 years using Office of National Statistics data. So here I've just got the data and I've plotted it in a simple manner in a line graph. It's incremental data, so you have the data, the number of deaths in week 1, week 2, week 3, week 4, etc. Up here in blue is the total number of deaths in 2020. In black is the deaths caused by COVID-19. And in yellow, for example, is the maximum deaths over the last 5 years. So it's the this peak here corresponds to the 2015 bad flu epidemic. So the students can see this peak is about 17,000 deaths, whereas this peak here is about 23,000 deaths, so a lot higher. But obviously, plotting all the data like this on a line graph isn't very clear and it doesn't tell a story. So the students can discuss if they want to do calculations, such as percentages, if they want to select only certain data, or try different charts. For example, this is a story they can tell from a BBC article. Obviously, it's better to hold off reading articles until they've done the graphs themselves. But as you can see with the title, deaths well above the normal range, that's their message. And the way they're showing it is with that 2015 peak here and the current peak up here. This is another way students may choose to tell the data. It's similar with the weekly deaths from January to April, but this time it's showing above average deaths and below average deaths, and in red the COVID-19 deaths. A second question is what age group is most at risk? So students can compare UK deaths by age group using the same some data from the UK Office of National Statistics. This is a different type of data. It's not deaths over time, but it's using week 18 of 2020 as a case study. These are actually the charts from the Statistics Office. I don't think they're very clear. They don't illustrate the disproportionate numbers of elderly people's deaths. And it's mostly because they have categories with intervals of 10 years in some cases, 30 years in some cases. So students could decide to try different age categories to emphasize their point, or they could try different types of charts. So for example here, I've done categories down here where each interval is 20 years, and this is a pie chart. So it's very clear that the 60 to 79 and the 80 plus categories are over 3/4 of the deaths. So student can ask, is it because there are more elderly people in the population maybe? or is it because they're getting sick more? To do this, it's a different data set. It's cumulative data because that was all that was available for infection rates. So here is cumulative death and cumulative infections. And so here they've been put into the different categories from the previous, like in the previous one. This is a similar graph to the previous graph. This is looking at the population number, the proportion in the population, and this is the cumulative cases, so infections. So these two categories, yellow and light blue, they're about a quarter of the general population, and the cumulative case, in case of infections, they're about half of the population. So it's not because there are more elderly people, and it's not because they're getting sick more that they're dying more. This is a bit of an indirect way to look at things, and students can think about doing calculations and calculating the case fatality rate like I did down here. This is plotted here by the age categories. So it's clear that elderly people are dying of COVID-19 disproportionately. These numbers are actually a bit high, 40%, 30%. So an article showed these numbers. So in that category, the 80+ category, around 15% mark. This is different countries. And in these categories, from 1 to 10%. So probably in the UK data, there was strong selection bias, and people who are mildly sick are not getting tested, whereas very sick people are getting tested. Thank you very much.